Create, alter, and drop are like the three main actions you can do with a Lego house. Create is when you first snap pieces together to build a new house or a new table in a database. The basic sentence looks like create table family id int name varchar 50, you name the house table, give it rooms columns, and decide what each room can hold data types. Alter is like adding a new room, changing the size of an existing room, or repainting a wall. You modify something that already exists. Example: alter table family add birthday date, adds a new column. Drop is the demolition crew that tears the whole house down. Drop table family removes the table and everything inside it. The words create, alter, drop tell the database what you want to do, just like build, renovate, or tear down tell a builder. Think of a table as a bookshelf. Each column is a shelf, and the data type tells you what kind of books or toys can sit on that shelf. Big picture books need a large shelf. Varchar 255 tiny picture cards fit on a small shelf. Char 10. When you define a table, you write create table toys toy, id int name varchar 30 default unknown. The default part is like putting a label on an empty shelf that says, if you forget to write the name, write unknown for me. You can also say a column cannot be empty, not null. It is like saying every shelf must have at least one book. Managing structures means you can add, remove, or change shelves later with alter table commands, just like moving a shelf in a real bookcase. Constraints are rules that keep the data tidy, like a classroom rule. No one can sit in two seats at the same time. In SQL, you can add a primary key which guarantees each toy has a unique ID. A unique constraint so two toys cannot have the same name. Or a foreign key that links a toy to its owner in another table, making sure the owner really exists. Indexes are like a library card catalog. They do not change the data, but they give the database a fast shortcut to find a book. You create one with create index ix name on toy's name. The index takes extra space just like a real catalog takes paper, but searching becomes much quicker. A database schema is like a city map that shows how roads, tables connect. As the city grows, you may add new roads, close old ones, or change the direction of traffic. Schema evolution is the process of making these changes without breaking existing buildings. A dependency graph is a picture that shows which tables depend on which other tables, like which road leads to which neighborhood. If you drop a table that other tables rely on, the graph shows a broken link. Tools often read this graph to decide the safe order. First add new tables, then update foreign keys, then remove old ones, similar to how a city planner would reroute traffic before demolishing a bridge. Some databases treat DDL commands like a magic wand that instantly saves the change. You cannot undo it later, just like tearing down a wall cannot be automatically rebuilt. Other systems, for example PostgreSQL, allow DDL inside a transaction. You can begin, create table test, open parentheses, close parentheses, rollback, and the table never appears, just like you can start building a sandcastle and then brush it away before anyone sees it. The rollback behavior depends on the DBMS. Understanding whether your DB can roll back DDL is important, because in a production system, you may want to try a change on a test copy and be able to revert if something goes wrong. Just like only a teacher can move desks in a classroom, only certain people can run DDL. Permissions or privileges are granted by a database administrator, DBA. Grant create alter on schema public to Alice lets Alice build or change tables in the public area. Revoke drop from Bob stops Bob from deleting anything. Having the wrong permission is risky. If a regular user can drop a table, they could accidentally erase important data. Good security means giving the smallest set of rights, needed the principle of least privilege, and regularly reviewing who can run DDL commands. When you add a column, the database has to allocate space on the disk for every row, even if the column is empty. Think of a spreadsheet. Adding a new column adds a new cell to each row, consuming more memory. Indexes improve read speed. They let the database find rows faster, just like a sorted list helps you locate a word quickly. But each index also uses extra disk space and must be updated whenever the data changes, which can slow down writes. Some databases allocate pages blocks of storage in fixed sizes. Creating a large table may cause the system to request more pages, similar to asking the librarian for more shelves when the collection grows. Good naming is like giving each Lego piece a clear label. TBL underscore customer, COL underscore customer underscore ID, IDX underscore customer underscore name. Consistent names make it easier to read and avoid confusion. Versioning means you keep track of every change to the schema, often with a number like V001 underscore create underscore customer dot SQL, V002 underscore add underscore email dot SQL. Migration scripts are ordered steps that move the database from one version to the next. Running them in order is like following a recipe, each step builds on the previous one. Tools like Flyway or Liquibase store these scripts and remember which ones have been applied, so you can safely upgrade a development, test, or production environment without missing a step.